All right, this is a brief tutorial looking at how to use the crisscross method for multivalent metals. So this is a tutorial for if you are already familiar with what multivalent metals are, those metals that have multiple ionic charges. So because these metals that have multiple ionic charges can form ionic compounds with more than one ionic charge, we have to communicate which valence or which ionic charge it used to make the compound. So we do that by including a Roman numeral in the name, and you have already looked at this. So this is just a quick shortcut to figure out for me to show you how to determine the formula if you have the name of a compound. And we're going to do an easy example of, copper 2 chloride. So that Roman numeral tells us that it was copper 2 plus that was involved in making our compound. So to use the crisscross method, we do exactly the same thing we did before. We write the symbol of the elements, and we write their ionic charges, and we know from our periodic table that chlorine or chloride has an ionic charge of -1. And we know copper can have either a +2 or a +1 ionic charge. But in the name, it's told us that it is the +2. So this Roman numeral 2 tells us that it's copper 2 plus. So now that we know the ionic charges, we do exactly the same thing before. We drop the symbols, and this is an invisible one, and we cross the charges, and we end up with Cu, invisible 1, Cl2. But we know that we don't write ones in formulas, so this becomes Cu, Cl2. Okay. Before we move on, just remember that the rules for the crisscross still apply. You still have to put this in lowest terms. If it is a compound, that formula can be put into lowest terms. The second thing we'll look at is determining the name from the formula. So in this example, we are going to look at the formula Fe2O3. So because it's an ionic compound, we know that we can start by naming the metal first. This is going to be iron. And we know, so iron comes from here. We know that we can put the name of our nonmetal, O. So I'm going to write that right here. We don't write it as oxygen. We give it the ending IED. But you have to do a quick check, because whenever you are naming from a formula, you have to double check that you do not have a multivalent metal. But if you look on your periodic table, this periodic table right here that you have, you can see that iron has 2 possible charges, so it's multivalent. So you have to use a Roman numeral to communicate the ionic charge that was used for bonding. To do that, we do what's called a reverse crisscross. So this 3 comes up here, and this 2 comes up here. So it ends up that this becomes a 3 plus, and this is a 2 negative. Before you move on at this point, you have to make sure that the ionic charge of your nonmetal is correct. So we are saying, after this crisscross, that oxygen has an ionic charge of 2 negative, which if we check on our periodic table, is correct. So oxygen is showing our 2 minus charge here. So this means because our iron has a 3 plus here, this becomes iron 3 oxide. We're going to do one more example. We're going to do manganese, MnO. So if we're looking, and we're going to notice that there's no subscripts. So we know that there is invisible ones here. So this invisible one for reverse crisscross comes up here, and manganese gets a 1 plus, and this invisible one comes up here, and oxygen gets a 1 negative. But now you have to double check that the ionic charge for your nonmetal is correct. Oxygen has a 1 negative in this reverse crisscross. We know that oxygen's ionic charge is actually 2 negative. So we have to turn this 1 negative into a 2 negative. So to do that, we multiply both numbers by 2. So this becomes a 2 plus, and this becomes a 2 negative. Now our ionic charge for oxygen is correct, so we can name our compound. Mn, manganese. This 2 plus tells us that it's manganese 2, and O for oxide. Okay, so this is just an example. This manganese 2 oxide is an example of when the formula has been reduced, and then we just have to essentially unreduce it to get the correct Roman numeral. So this was just a quick tutorial on how to use the crisscross method for determining name and formulas for multivalent metals.